So I'm going to go ahead and go through this review. I think my copy said Chapter 9. Sorry for that, but first couple are just can you use a calculator. I'm not expecting you to do these by hand. So we have negative square root of 841, and so I'm going to switch to my calculator and do, let's see, negative square root of 841, and it should confidently give you negative 29. And we could check that if I have a negative and then 29 times 29, that should give us negative 841. And remember, the reason why this works is that basically out of the 841 comes the 29, and then the negative in front of it makes it negative. If I was to have the square root of negative 841, we would call that, what, 29i. Third root of negative 512. Okay, you need to know how to do the third root. So for my calculator, I have a kind of a fill-in root, and I can do the third root of negative 512, and that should give me negative 8. 125 to the 1/3. Our notes had something like a to the e over r, and that's the same thing as the rth root of a to the e, or we said that exponent could be on the outside. So in this situation, this is the same thing as 125 to the third r root in the denominator, and the third root of 125, since that is 25 times 5, or 5 times 5 times 5, it's going to be a 5. Oh, wait, no. We're looking for groups of 3 in a third root, so it's just 5. Square root of 146.25 is the closest to what whole number here? The way we check this is we go, look, whatever the answer is, this number squared should give us something close to 146.25. So we can just take each of these, square them, and go, which one is the closest to 146? So the answer must be closest to 12, because the square root of 146.25 is really close to the square root of 144, which is 12. We're going to approximate this, so the square root of 478, this is not going to be a pretty number. Square root of 478, 21.86. Tenths, hundredths, thousands, so how about 863? Okay, we could check this. This number squared should give us 478. Third root of negative 832. So that would be, once again, my third root of negative 832. Make sure that's right. 832. I have 932. Alright. So negative 9.405. And once again, I could check this by raising this answer not to the second, but we're saying this number to the third. Should give us 832. Negative. Graphing. When I graph this, we got a couple options. If you see this is our horizontal shift, you already know where to start this. See, normally we'd start at 0, but this graph has been shifted. To make a 0, x would need to equal negative 6. So that would be the first point that I would check. So let's call this negative 2, negative 4, negative 6, and negative 6 plus 6 would be the square root of 0, which is 0. So instead of getting at negative, or at 0, 0, we have negative 6, 0. That's enough to give kind of a sketch. Since it's a square root, I know what it's going to look like. We can just do that. If you're not sure, check a number right after that. Negative 5 plus 6 would be the square root of 1, which is 1. I could check -4, but that's not going to be nice. -3, -2. Why do I like -2? Because -2 plus 6 is 4, and the square root of 4 is 2. So -2, 2. So this is not a straight line. It's growing very slowly. And what about at the -7? Well, that would give me the square root of -1, where the graph does not exist. The idea is that we're not going to have square roots of negatives. We're not going to graph that on the real x-axis. So this is our graph. What is the domain? I believe in my notes we said that x is greater than or equal to -h, or really it's h. And since this is a positive 6, our h is -6. So greater than or equal to -6. You should also be able to see that from the picture. How far left does it go? -6. If I wanted that in interval form, -6 to infinity. Our range, the lowest y value, y is greater than or equal to 0, or 0, infinity. Simplify. Okay, so this is one where I'm going to rewrite it. What's our root? Remember, the root is the denominator, so the third root of -64. Now we have to decide, do I want that fourth power out here or out here? We're going to definitely want it on the outside. In fact, I think I just made a mistake, though, because I just noticed that that root is not just a fraction, but it's also negative. So this would actually become 1 over -64 to the positive 4/3. So this would become 1 over all of that. The third root of 64 would be -4, and -4 raised to the 4th would be positive 256. Simplify. This is wanting to see if you can kind of apply some of the rules. Some of the rules are going to be that if we have a negative exponent, we move things. Things that are negative down here, we move up. Things that are negative up here, we move down. So what do we end up with? 3 to the 2/5 times 3 to the positive 8/5. We'll deal with that in a minute. The x moved down there. I've got y to the 2/5, and on the bottom y to the 1/10. I'll deal with that in a minute. And I've got also x to the 7/4 and x to the 1/4. So let's go ahead and start with the 3's. 3 to the 2/5 plus 8/5 would be 10/5, or 3 squared, or 9. The y's are a little more complicated. I could bring this up and combine them, but I would rather just kind of treat this as a subtraction problem. So this becomes y to the 2/5 minus 1/10. They would need a common denominator, so 4/10 minus 1/10 gives us 3/10. So we're left with y to the 3/10 up there. Didn't simplify much. And the x's on the bottom, x to the 7/4 plus 1/4 would be 8/4, or x squared. And that is how we leave that. Simplify this. Remember, the idea is that I'm not getting a decimal in this. We are leaving it in radical form, so you need to break this apart. 54 is 6 times 9, or 3 times 2 times 3 times 3. Since I'm doing a square root, I'm looking for pairs of 2. So I pull out the 3's, the square root of 9, a 3 comes out, and we're left with 3 and 2, which makes 6 on the inside. X to the 5th, I could write out 5 x's and pull out 2 groups of 2, which leaves us with an x on the inside. Or I could think of this as x to the 5/2, which gives us what? 2 remainder 1. The 2 go out, the 1 that's remaining stays inside. Y to the 6th, I could write out 6 y's and circle out 3 groups of y, which would be y cubed. Or I could think of this as y to the 6/2, which is 3 remaining 0. 3 y's come out, none remain. Fourth root of 32, a to the 7th, b to the 13th. Fourth root of 32 is, I don't know. I know 32 is 8 times 4. 8, I'm going to go ahead and split that into 3 2's. 4, I'm going to split that into 2 2's. So, pulling out groups of 4, a 2 comes out, and we're left with a 2 on the inside. Make sure you put that fourth root there. The a's, I could write out 7 a's. Circle 4, an a comes out, we're left with 3 on the inside. I could think of that as a to the 7/4, which would be 1 remainder 3. 1 comes out, 3 remain. B to the 13th. And then I could circle 3 groups of 4. So b cubed would come out with 1 left over. Or I could think of that as b to the 13/4. So that would be what? 3 remaining 1. 1 would be remaining in there. Square root of 2 times the third root of 5. I cannot multiply these together because they do not have the same root. Well, what is this though? Let's rewrite this as 2 to the 1/2 and 5 to the 1/3. Could I give them the same denominator, the same root? 2 and 3, we could make them both into a 6. So this would become 2 to the 3/6, 5 to the 2/6. Now I could go back and go, look, these are both now the 6th root of 2 to the cube and the 6th root of 5 squared. Of 5 squared. So now I can bring them together as the 6th root of 2 cubed times 5 squared. Or I could think of that as 8 times 25. So it would be the 6th root of 200. I'd be fine with either this or this. The idea is just to bring them together. Third, 3 square root of 20, 5 square root of 80, 4 square root of 500. Currently, I cannot combine these. They are not the same radical. But 20 is the same thing as 4 times 5, or 2 times 2 times 5. So that means a 2 comes out, multiplies with the 3, so we have 6 square root of 5. 80 is what? 8 times 10, 2 times 2 times 2, times 2 times 5. 2 pair of 2's come out, so really it's like a 4 coming out. 5 times 4, that's minus 20 square root of 5, plus, what is this? 5 times 100, 5 times 10 times 10, 5 times 2 times 5 times 2 times 5. What comes out? We got a pair of 2's, we got a pair of 5's, so a 5 and a 2 come out, that's like a 10 coming out. So we have 40 root 5. So now we have 46 square root of 5 minus 20 square root of 5, about 26 square root of 5. I will tell you right now, this has a big common mistake, so please be careful. If I just ask people to multiply these, they have no problem. When I ask them to do this in this question, all of a sudden people start making up other stuff. So when you multiply this, the 7 and the 2 multiply to give us 14, and root 5 times root 5 multiply to give us the square root of 25. Now I'm going to simplify that, because the square root of 25 is just 5, and then 14 times 5 is 70. Okay? That is, like I said, a common mistake. Please be careful. Minus 7 square root of 5 plus the 4 and the 2 multiply to make it 8 square root of 5 minus 4. These two combine. Negative 7 plus 8 would be plus 1, or just plus square root of 5. We also had a minus 4, so 70 minus 4 would be about 66 minus the square root of 5. If you want to miss this, just square both of them. That's not what this means. Please don't do that. What does this mean? This means square root of 3 minus 2 root 5 times the square root of 3 minus 2 root 5. Root 3 times root 3 is the square root of 9, which I'm going to rewrite as just 3. When I multiply these, that 2 multiplies with nothing. Well, there's really a 1 there, so it stays minus 2. The square root of 3 times square root of 5 makes that square root of 15. Same here, this 2 has nothing to multiply with, so it's really negative 2 times 1. Square root of 5 times square root of 3 would be square root of 15 again. And negative 2 times negative 2 would be positive 4. Root 5 times root 5, root 25. Which I'm going to simplify to make that a 5, which I'm going to multiply to make that a 20. So what do we end up with? 3 plus 20 minus 2 minus 2, how about minus 4 square root of 15? That's how I'd write that. How do I simplify when I have a radical in the denominator? Well, this time we're going to use the first option, which is to multiply the top and bottom by square root of 40. What you would end up with is negative 5 square root of 40 all over. This basically becomes the square root of 1600, which is just 40. Now you would need to reduce this. 5 goes into 40 8 times. So I would have negative square root of 40 over 8, which is still not right because we should have simplified the square root of 40. See, square root of 40 is 4 times 10, or 2 times 2 times 2 times 5. So that's like negative 2 square root of 10 over 8. 2 and 8 are both reducible or divisible by 2 to give us negative root 10 over 4. I would encourage you to make your life easier, and rather than try to simplify at the end, simplify at the beginning. Negative 5 over, we already saw the square root of 40 becomes 2 root 10. Messed up on that? Well, that's right. And then what I can do is multiply the top and bottom by just the root 10 to give negative 5 root 10 over 2 times the square root of 100, 2 times 10 all over 20. And then I would divide the top and bottom by 5 to give us negative square root of 10 over 4. This one, most common mistake, people will just do this. This will not work because this becomes the third root of 25, which does not simplify. See, in what I said in the notes, it says that give each one what it needs. This needs 3 5s. We currently have 1, so it needs 2 more. See, what that would do is that would give me the third root of 125, which is 5. So if it has a third root, it needs roots of 3. What will be left on the top? 2 times the third root of 5 squared, or 25. How do we deal with this? Well, a lot of people want to just multiply it by root 5. That will not work because this will distribute to both, and they won't all disappear. This is one where we have to use option 2, which is to multiply by the conjugate. So the square root of 7 plus 5 times the square root of 7 minus 5. And I cannot just do that. The radical there. Remember what I do to the bottom, I must also do to the top. So that the top becomes negative 4 root 7 plus 4 root 5 all over 7 minus root 35 plus root 35 minus 5. 7 minus 5 is 2. Please don't leave it like that. 2 divides into both of those 4s, or I could divide the top and bottom by 2, whatever makes more sense to you. So this becomes negative 2 root 5 plus, I messed up somewhere, I should have been a 7, sorry. Negative 2 root 7 plus 2 root 5. Write this in lowest terms. What can we do? We can simplify the square root of 24. How about 4 times 6? 2 times 2 times 2 times 3. Out comes a 2. 6 plus 2, square root of 6 all over 2. That 2 divides into both the 6 and the 2, so it needs to be reduced to 3 plus the square root of 6. Find the distance between these points. Well, there is a formula for this. I would encourage those of you going into trigonometry to know that formula. For those of you who are not, I also encourage that you can draw a picture. Negative 3, 1, 2, 3, 4, 5, 6, 7, 8. 2, 1, 2, 3, 4, 5, 6, 7. I want the distance between these 2 points, which is basically the hypotenuse of a right triangle. I know that right triangle, a squared plus b squared equals c squared. A is my change in x, b squared is my change in y, and c is my distance. So what was the change between the x values? Well, we went from negative 3 to positive 2. Count the spaces. 1, 2, 3, 4, 5. Change in x is 5. So 5 squared, or 25, plus change in y. It went from 8 to 7. It went from 8 down to 7. It went down by 1. So 25 plus 1 is equal to distance squared. 26 is equal to distance squared. Make sure that you square root it. Simplify if necessary. But in this situation, it's just the square root of 26. Solve for the missing side. Well, this is still a right triangle. So a squared, or 12 squared, or 144, plus b squared, which we don't know, is equal to c squared, or 17 squared, or, I want to say 289. I don't want to get too cocky. What was it? 17 squared. So when I solve for b squared, b squared is equal to, I believe that's 145. Minus 144. And so then we square root it. And so we have the square root of 145, which we do need to check and see if that simplifies. I know that 5 goes into it 29 times, and I think those are both prime. So that would be our answer. Solve the equation. This should be give me points on the test. To undo a third root, we use a third power. I do it to one side, do it to the other. I get 5x is equal to 2x minus 3. 3x equals negative 3. Divide so that x equals negative 1. Make sure you stop and check these. Third roots don't actually have extraneous solutions. It's the even ones where we get the restrictions. But if you're not sure, we basically would have the third root of negative 5 is equal to, what was that? Negative 2 minus 3. So the third root of negative 5, which is true. The third root of negative 5 equals the third root of negative 5. On this one, the most common mistake I saw was people just trying to square this. My note said to isolate that first, so move the 5 first, so that the square root of 7 minus x is equal to x minus 5. I undo the radical now that it's isolated by squaring both sides. This becomes 7 minus x is equal to x squared minus 10x plus 25. That was just x minus 5 times x minus 5 distributed out. We are going to, since it's quadratic, set it equal to 0 by adding x. and subtracting 7 to get x squared minus 9x, what is that, plus 18? The only way that we've learned so far to solve these is to factor them. So that would be x plus, probably actually minus 6, x minus 3, setting each of these equal to 0. We get x equals 6, we get x equals 3. Maybe. So you check these. Okay? I should be able to plug in a 6. 6 minus 1. I'm sorry, 7 minus 6 is 1. The square root of 1 is 1. 1 plus 5 is 6. I get 6 equals 6. Fine with that one. Try the 3. 7 minus 3 is 4. The square root of 4 is 2. 2 plus 5 is 7. 7 is equal to 3. That is not true. Throw out the second answer. It's extraneous. What do I do when I have several radicals? Well, I isolate one. It's not going to be pretty, but at least we can get rid of one of them. What we can do now is square both sides. This gives this left side just an x plus 4. The right side is a little messier. 1 minus square root of 1 minus x. 1 minus square root of 1 minus x there. Negative 1 times negative 1 is positive 1. Let's see. Plus 1 gives me plus 2. Square root of 1 minus x. And then square root of 1 times square root of 1 minus x gives us positive 1 minus x. They cancel out there. So what do we have here? X plus 4 is equal to 2 minus x plus 2. Wow. That's a lot of horrible work. But what we did was we got one of the radicals to disappear. What I need to do is now isolate the other radical. So now that I have 2x plus 2 is equal to 2, 1 minus x. I'm not liking that 2. It's not isolated yet, so I'm going to divide everything by 2 and get x plus 1 is equal to the square root of 1 minus x. Now that that other radical is isolated, square both sides. X squared plus 2x plus 1 is equal to 1 minus x. Add the x minus the 1. We get x squared plus 3x equals 0. Factor that. They have an x in common, leaving us with x plus 3. So I get that x equals 0 and x equals negative 3. Maybe. Check the 0. Square root of 4 is 2. 1 minus 0 is that, so 2 minus 1 equals negative 1. That didn't work. Check the negative 3. Negative 3 plus 4 is 1. Square root of 1 is 1. This becomes square root of 4, which is minus 2, equals negative 1. That one's correct. 1 minus 2 is negative 1. So we keep the negative 3 this time. By the way, that's a good practice question, more like a pre-calculus question, kind of showing what we do with it later. This is not on the test. So 24 is not on the test. If this question made you sad, at least be happy to know this will not be on the test. Alright, let's get to the easy stuff. So here we have imaginary numbers. We can treat them like variables, which means I could subtract, or I can distribute this to make this minus 3 minus 6i. Bring the rest of it down. I can combine like terms. Negative 2 minus 3 is negative 5. Bring these together to give us negative 8i. That's it. We can add them, we can subtract them, we can distribute them. Negative 4 times 3 is negative 12, plus 4i, plus 6i, minus 2i squared. You need to catch that I squared can be simplified. I squared is the same thing as negative 1. So negative 2 times negative 1, this whole thing becomes a plus 2. So I really have negative 12 plus 10i plus 2 at the end, or negative 10 plus 10i. How do we get rid of it if it's in the denominator? Well, I could multiply top and bottom by I, but this is one that requires our option 2. I would use the conjugate again. So 1 minus I, the conjugate of that is 1 plus I. The top, 7 times 1 is 7. I'm going to bring these separate here. Let's see. So 7 plus 7i plus 1i plus I squared. I squared is negative 1. So 7 minus 1 is 6 plus 8i on the top. On the bottom, 1 times 1 is 1 plus I minus I squared. Middle zeroes out. I squared becomes negative 1 minus negative 1 becomes plus 1. 1 plus 1 is 2. You have to catch again. The 2 divides into the 6 and the 8, so that our final answer would be 3 plus 4i. And last but not least, and this is really, I think, a first concept, but remember we saw that I is the square root of negative 1, so that I squared is negative 1, I to the third is negative I, and I to the fourth is positive 1. This is all you need to know because of the idea that it repeats at this point. So I to the fifth is the same as I to the first, I to the sixth is the same as I squared, so that I to the 35th falls along which one of these? Well, what I do is I pull out all the groups of 4. 4 goes into 35 8 times, with 3 remaining. Now I can make that a decimal, but this remaining 3 i's basically means that I to the 35 is the same thing as I to the third, which is negative I. Check it. If I were to keep going, I to the third is the same as I to the 7th, I to the 11th, 15th, 19th, 23, 27, 31, 35. What did we do? We just took out all those groups of 4 that didn't make a difference, and what was remaining was our answer.